San Francisco is the birthplace of self-driving, I guess. NVIDIA and Mercedes are here to show off their new full self-driving level 2++. So not full self-driving at all. In fact, our subject matter expert would not even describe it as full self-driving. And yet, here we are. In fact, it's right there. I'm going to take the gray one, not the blue one. But, you know, full self-driving, Mercedes. Like, this is our future, right? Eventually it's going to be mandatory because insurance and liability reasons. Like, there's just no other way to avoid that. Well, you could say that I'm a man on a mission. I'm here to experience the new version of the self-driving software, level 2++ on Mercedes, that's coming soon, thanks to the NVIDIA and Mercedes partnership. I'm literally on mission.
To reintroduce you guys to me, my name's Armand. I'm a senior product manager here at NVIDIA, and I'm on the user experience team. So I actually work on this product, and I want to make sure that the driving behavior and driving style, everything is nice, comfortable, and safe, and behaves like a nice human driver would. So
neat.
That's what I work on.
Yeah, the sensor package that's visible from the outside is not ostentatious, let's say.
It's very subtle, right? There are 10 cameras and 5 radars here, right? So that way you can see the world around it, right, and decide what the car should do in these situations.
And so this is the real world implementation of the vision language model running in parallel with the, as kind of an end-to-end model running in parallel with the more traditional model.
That's correct. So the way I like to think about it is, imagine you have an old school driver's instructor's car, right? So like a driving school car. So you have your driver's seat, right? You have gas, brake, and steering wheel. There's also one on the passenger side, right? So the end-to-end model is in the driver's seat, right? It's doing 95% of the driving. It's doing the majority of the heavy lifting on how to turn, when to brake, when to stop, what's going on to understand the world around it. And then we have that classical model there kind of sitting, making sure everything's safe and will brake or take over steering if needed, right? Based off the trajectories that come out from that end-to-end model.
Yeah, and I think this is one of the things I was reading in the National Highway Traffic Safety Report, I think. This was one of the things that as a safety feature they sort of liked because, there are aspects of language models, whether it's a vision language model or otherwise, that we don't understand, but we do understand sensor input and raw data. And it's like, oh, both models running at once with kind of the one that is algorithmically known, let's say,
exactly,
with its hand on the brake is good.
Yep, exactly, right. For us, our first priority is always safety, right? So, in partnership with Mercedes on this one, right, having those two trajectory outputs, right, acting as redundancy to, again, have those hard rules, right? Don't drive into curbs, don't run a red light, right?
Don't run over the pedestrians.
Exactly, right. You can have those rules that are in place in order to, just account for any potential quirks.
Well, consider, this is kind of challenging. It's like we have the red lights and we have the thing, but also in the field of vision is another set of red lights. And it's like, oh, you can also have a crosswalk where there is no red light, but you're just supposed to know to stop in the crosswalk.
Yep. Yeah, so you'll see on this route, we'll have some unprotected left turns, we have some stop sign controlled intersections, we have a dedicated right turn lane that we have to navigate through. So you get a nice variety of scenarios that we get to experience here.
This is the computer. This is the Orin that's actually in the Mercedes. It's packaged a little different, but it's the same software stack. It's the same thing that we're used to seeing on GitHub or being able to run software on or whatever. But this is what is actually running the experience, doing the vision processing and information from the radar. That's it. And it's already there. The cars that we're driving are shipping cars, but with a different software stack, which maybe will be available next year. Maybe the year after. We'll see. But that's it. That's all the compute you need.
So for this system, this is what we call our level 2++ system, right? So the way we think about level 2, right, is your eyes are on, right, but your hands can be off, right? For level 3, both eyes and hands can come off, right? And for level 4, eyes off, hands off, and your mind off, right? You could be in the back seat if you wanted to. But in this case, right, as we're going to come up here, we'll make lane changes. The system will initiate those lane changes to follow the route. So you can see the route set in the head unit there. We'll make sure that we follow that routing. So if we need to get into a right lane to make a right turn, we'll do that. But also trigger any lane changes for overtaking, right? So if you have someone who's moving really slowly ahead of you, right, the car will lane change to go around that car. And then as we get into the more densely populated kind of urban areas, right, with restaurants and people walking around, right? If there's a double parked car, you've got a FedEx truck or a delivery vehicle. If it sees, hey, this guy's stopped, someone might be coming out, it can drive around, it can be cautious, it can wait, so it can kind of identify all those situations and handle those as making that determination of what to do and how to get around it. The other fun part about it, it is still a level 2 system, so if you wanted to, right, he could ask the system to make a lane change, right, so you can also do a driver-initiated lane change where he can hit the turn signal stock and it'll make the lane change for him. We also can do a little bit of collaborative steering, right, so if he sees, hey, there's like a pothole or something I want to steer around, the car can actually let him take over steering briefly, right, and as he returns lane, he lets go, right, and it'll resume driving, right, so it doesn't disengage the system in that way. What's this guy doing? Let's see, it's braking.
Some wild drivers. Yeah, this is good though.
With Mercedes.
Yeah, I was kind of surprised like in the PR event, the better answer for a lot of that was NVIDIA's vision is to be a tool company, but we're also building proof of concept to show that our tools can do it end to end. So if you have folks like Rivian or Mercedes that want to substitute in their own components, fine.
Yeah.
We're still a tool company.
Yeah. You can take as much or as little as you like, right?
Yeah. That's also what excited me about the VLM model being on GitHub, because it's like, I can do this with a remote controlled car. Badly.
Right, so you can see even here, right, as we're going to cross this hill, the road on here is tore up. There's no lane lines, right, it's very rough pavement. But we can infer, right, with the other cars, right, I need to keep my lane here, right, and maintain kind of this lane that doesn't really exist with this faded pavement in order to kind of follow along and follow the flow of traffic, right? And that's something where you can do it with an end model, by teaching it with this data that shows, hey, you can actually just follow along. You don't need to freak out. You don't need to find a lane line, right? It'll all be okay.
Now, it's normally it's the case on this drive. I mean, it's a preset route, but it's not a pre-trained route. Is that accurate?
That's correct.
Yeah, so this is part of the mathless innovation.
Mm-hmm.
Okay.
That's exactly right.
We've seen other self-driving technology in the past where we get millimeter accuracy scans of the road, and that is not what is happening here. This is not a pre-trained drive route or pre-trained with like a millimeter accuracy level scan of the road. This is just a pre-selected route that is not unreasonable.
Yeah, the goal of the route is to show a variety of scenarios where you can see unprotected left turns, you can see dense urban areas with people crossing the street, restaurants, things of that nature, all-way stop signs, double parked vehicles. So you get a variety of scenarios that we have to counter when driving every day. Make sure that we have the right of way, no problem. And that's the car turning. All right, let's make the turn.
Now, in that kind of a scenario where you've got the other cars coming to a stop, but they have not stopped yet, is the LiDAR and the algorithm smart enough to say, it's like, I can tell that those cars are decelerating, so it's probably safe to turn?
Mm-hmm. Yeah, so it knows right-of-way order at stop signs, right? So it can tell who's arrived first, who's arrived second, so it knows the priority there. And then it can also detect the velocities of the other vehicles and people around, right? So if you have someone walking on the sidewalk, right, you can tell, is this person moving quickly, right? Are they likely to jaywalk? So trying to predict what may happen in those scenarios, that way it can be cautious.
And so like the other stop sign, if is it smart enough to know that the one car is not decelerating, it's probably going to run the stop sign. So even though it has right of way, it's like, I'll stop anyway.
I'm going to wait a second. Yeah. So we really prioritize being kind of safe and cautious in those scenarios, right? Especially in those types of intersections where it's likely someone's going to go out of order. Right?
Modeling someone else's behavior. That's like, that's like the big deal. If you read The Bicameral Mind, like that's when it's like, oh, animals that can predict the mindset of other animals, like something has leveled up there. Lots of delightful unpredictability on our drive.
It's an unpredictable world we have to drive in.
The RNG is favoring us.
All right, so we paused while that guy kind of jumped ahead of us, no problem.
And so here, this looks really challenging because we've got cars pulling out, I got the UPS truck. There's a lot going on up here.
Correct. So yeah, so you can see this guy's double parked, right? He threw his hazards on. We're gonna see what's going on here. We see a door opening, right? So it's trying to understand the scenario in front of it, right? You see this person getting out to cross the street. Okay, now we can start to creep forward as soon as the scenario clears up.
And it dealt with the UPS truck by going into the oncoming traffic lane. And then there's another truck over here.
Yeah, so you can see it's just gently kind of navigating through the narrow space, right, and able to kind of return back to its lane here.
Wow, this is an incredibly impressive demonstration, this aspect. Yeah, I can't believe it dealt with that automatically.
Yeah. And that's where really you see the power of the end-to-end model, right? You train it enough on scenarios like that, right? It's very difficult to write rules. Okay, if this guy jumped the queue.
Wow, that's amazing. We almost got T-boned. But the car was like, let's brake kind of hard.
Yeah. Right, so it's pausing there. You can see some people over there. Great. And we got some jaywalkers here. Just slow down, let them clear, then we'll proceed forward. Right, so I see some reversing. Let me brake. Right.
Yeah, that was literally a physical answer to the vector question that I had earlier, which is like, there's something that's entering my path.
Yeah.
I'm going to stop. So this is level 2++. I would say that the experience we just had was level 4 or 5.
It's right. So the way we think about the difference between level 2, level 3, and level 4, right, is very much the responsibility and the design of this product is hands off, but your eyes are on, right? So there still will be corner cases where the driver may want to intervene, right? So again, he's going to adjust the speed if he feels like the speed limit's too slow, right? He may want to change lanes, so he's still in the loop, he's still able to. The design of this product is to enable that, right? Whereas a level 4 product, right, we think of that very much as eyes off, hands off, mind off, right? You can be in this seat, it doesn't matter.
Yeah, so what I'm hearing though is that, yeah, it is level 4 capabilities, but we don't know what we don't know, and so the safety aspect is what keeps us from calling it level 4.
This is designed as a level 2 product, right? So, it's
understood. Yeah. The insurance company is, for the purposes of insurance, and yeah, I get it.
So this street will get a lot of, always stops. Right? We have some pedestrians, maybe some more double parked vehicles. Hard to tell. Looks like we have a bobcat on a trailer. Right, so we'll see. I think you guys are getting a good demonstration of all the capabilities here.
So this setup with the Tesla in front of us was really interesting because we got the sloped hill on the side. The black van on the right is about to back out into the intersection. The car on the left is picking up a meal. Meanwhile, the rest of the intersection is operating normally. And we spent an inordinate amount of time in this intersection. I'm not really sure if this was the Tesla human driver or the Tesla self-driving, but the car was content to just sit here and let all of this play out, which is very interesting, I thought.
And not a lot of space here.
That person's been driving around the block.
And so it's not like yep, there's someone here. Right?
Yeah, it's like PEDs.
Yeah, people are unpredictable. So here's another double parked truck. Okay, so we can see, okay, there's this Waymo that's going ahead, or sorry, this Tesla going ahead, right? We can kind of follow. What are they doing? Right, oh, they're parking. Okay, let's cautiously pass them, and then we'll turn back to our lane here. Nice and slow, not anything too crazy, not too aggressive. Let's go ahead and fall back in line of traffic.
Yeah, it knew enough to be able to get into the other lane as well. Like, it knew the state of the oncoming traffic, 3 cars ahead.
I know my opinion, it doesn't matter, but you are product manager, correct?
Yes.
I was an early adopter of full self-driving on Tesla. I drive a Tesla every single day, and I don't trust it. But like, this is incredibly impressive. I would trust this.
We're hoping, at least with our approach here, right, that we can build that trust and that sense of safety, because that's ultimately what's paramount to us, right? It's an ADAS system, right? It's to help drivers. right? So if you're driving in an unfamiliar area, right, you know, if I was in Kentucky, I don't know the rules, right? Can I activate the system? Can it, you know, help me navigate that safely? You know, is kind of our intent here with this.
Now pay attention to what's happening here, because, you know, we just navigated through that thing where there was a car on the right. There was a little bit in our lane that was parked, and then the Waymo car. And these two cars at this intersection are not really sure that the car knows what to do with it. And so because it thinks they're stopped too long, it starts to go around. And so this is the first time that our driver had to do a manual intervention, because the you know, the self-driving Mercedes had enough of this and wanted to get around these two cars. I like how it's acting very sus of what's going on with the Waymo car.
It's trying to understand, right, is this person going to turn in front of me, right, regardless of what the vehicle is, right, and it just wants to make sure, okay, let's see what's happening here, let's take a second, and see, like here, it's like, oh, should I go around? No, okay, and this guy stopped, and then you can pull it back over, right, so that's where that collaboration comes into play, and the other way.
It's one mistake, it's not too bad.
Yeah.
Like I said, still early dev software. Right?
Yeah.
You guys are getting the sneak peek.
Yeah. Because it's like, what is this person doing? I agree.
I cannot overstate how impressed I am. Like, this is...
We're not going to say the word, but we're in that. You can see the logo on the screen because the editors are awesome when they put that in. But this is a currently available model, just with different software.
That's correct. And the software will be available next year. Mercedes announced details and pricing for this option, but you'll be able to buy this, right, and use this in your own vehicle.
That is, that's bananas. That is absolutely bananas.
It's because they were there, right? It's like, okay, wait, I need to get over. You're blocking my lane, right? So then this is just gonna wait and try to get out.
It knows. It knows. It knows the Waymo is there in the way. Because we have to go the other way. Cart full. That's okay. Yeah, nice. Oh well.
He collaborated a lot.
A little manual operation there.
We're still working on it. It's not done yet.
If we were in a Tesla, we would all be dead. So in terms of the level of self-driving, it says it's 2++. That's what we're talking about here. But
I'm not driving, by the way.
I don't think that you would describe this as full self-driving.
No, not for this product. Not quite yet. No.
That's going to be like level 4 or 5. Mm-hmm. But if this is 2++, 4 or 5 is going to be nuts.
We're excited for what's to come.
Mission accomplished. That's not for whom the bell tolls. Oh, that's just the time. So full self-driving is in, and that experience makes me think that, I mean, look, full self-driving is really not that interesting to me until it can legit take over. Like, it's just going to run the whole thing. And I think that they're on a path, finally, where maybe that could be a thing. Most of the other self-driving technologies that I've experienced really didn't feel like it was eventually going to take over. And so it's the weird state with AI, where it's like AI is doing something, it's doing something really interesting, it's maybe going to affect productivity, but the human being can't let go. Isn't that the story of like all AI in all scenarios? But this is the first time where I felt like they could actually get it to a point where the human can let go. It's going to take more iteration, it's going to take more engineering, it's going to take more data. They did answer later, the data that went into this drive was all real. There was very little synthetic data except for some of the edge cases, but the real driving data was all real, like except for like the dealing with the pedestrians and stop sign weirdness and the thing where we almost got T-boned. Like, there are synthetic data points in the data set for that, but the vast majority of it is real, actual data, highway, city, traffic, you name it. So very, very impressive. So I've spent long enough in San Francisco, it's time for me to go back. I'm going to leave now. It's fun. It's been a fun, interesting self-driving adventure.